with that, we will go ahead and segue into our third talk, which is going to be more of a technical talk, and it's about something that all of us should know as developers, which is debugging. And Aaron and I actually have a funny story about this. We did a really comprehensive debugging video about a year ago, and
this is take two. That's all they need to know.
Yeah, and it was really exciting, and I knew that loads of people were going to get into it, and then I accidentally deleted the video, so I never saw the light of day. So
it happened.
But yeah, Aaron and I have known each other for a couple of years now, and he's a very experienced developer. He's done work for Facebook. He's done work for several companies. He also has his own company called Stagecraft, where he develops plugins in Juice and C++. And today he's going to give us a whistle-stop tour of debugging. So there are several parts of this discussion that could be talks within themselves that could take several hours or even days to go through all the different considerations. But he's just going to give us a general overview of some general tips that you should know as a developer. And I will hand it over to Aaron to go ahead and fire away.
That's what I was going to say. Josh, I think when we did that first one too, we were both like, didn't have jobs, didn't have anything to do. I think we talked for like 3 hours. So you would have had too much editing to do anyway. So it's better that we do. Now I'm constrained to like an hour on this one. That's why it's really going to have to be a whistle stop tour.
Fantastic. Cool. So where would you like to start, Aaron?
Well, so let me share my screen first. Hey, if I come to that ADC in person, by the way, and there's not a rooftop poker game and disco, I'm going to be disappointed.
You'd be surprised. There's karaoke, there is an open mic, there is a quiz night, and there is potential for electronic music jamming next year. So.
Oh, I like it. I like the electronic music jam. It looks like I updated Zoom when we started this, and I got to allow it to, and I got to quit and reopen. I will be right back.
Okay, cool. So I guess, all right, I'm going to freestyle here and just tell you about some other things that are happening. Once again, as I mentioned before, Cycling 74 have been making a big announcement about something they've been working on for quite a few years, at least 5 years from my knowledge, and that's called Project Rainbow, which enables you to take a Max MSP project and export it to VST/AU formats. It allows you to export it to WebAssembly, so you can put it on a web page. You can take it and put it on a Raspberry Pi, and you can also take it and just and actually export it to C++ code within a Juice project. So you can develop all of your DSP within Max MSP itself, and then hit a button and it'll just export it. It'll open up a Juice project, create a new project for you, and you'll be able to create your UI in Juice. And so this is a really exciting opportunity to help even more people get into audio software development. And we will have one of the first tutorials on Rainbow that will be debuting tomorrow. And this is in collaboration with Music Hackspace. And along with that, we're going to be doing a workshop where certified trainers in Max MSP will be able to help you learn the ropes of Rainbow and get started. So be sure to stay tuned tomorrow for that. And with that, I will pass it over to Aaron. You're back again.
Yeah, gone for just a second. RNBO, Rainbow, this is what you were talking about, right?
That's right, yeah.
On the screen there? Yeah, I hadn't heard of this until you started talking either, but it does look really interesting. I think it's going to put some of us out of jobs.
Yeah.
Right. Okay, let's dive into debugging. We got about an hour. Like you mentioned a couple times, I'm not going to hit on everything, and you can feel free to interrupt me, Josh. We can kind of go back and forth on this because I don't have a formatted presentation. I was sitting around last night and I made this list here of just general topics that we could discuss, right? Mm-hmm. So I've been 25 years or so, I've been a code writer professionally, and about maybe 17 of those have been Juice and audio related. And 10 years ago, I would find myself way too often, the code base was getting larger, and I would find myself way too often staring at a computer screen, like 6 hours in, trying to figure out where a certain bug was occurring, and realizing that I wasn't good at navigating my own code, and I didn't have as good an understanding as I should have to the tools available for debugging, and how to quickly navigate through the code and figure out what part of the code is causing the issue that you're seeing, right? So it's something I've gotten a lot better at. And I started thinking a while ago, like, well, what would I tell myself, 15 years ago, if I was just starting out writing code, about how to like grow that code base and not have it become a mess, not have it become spaghetti code, not have it become where you're chasing down every little rabbit hole to figure out what in the code is messing with you. So this is not meant to be any kind of an exhaustive list. I'm not a deep expert on all the debugging tools that are out there. There's a number here that we're not going to talk about. And of course, every IDE is a little different. Every environment's a little different. So it's, like I say, it's not an exhaustive list, but it's a set of conversations, some of which are general enough that I think they bear on all of our work. No matter what you're doing, you're going to deal with stack traces and breakpoints and deadlocks and things like that. But then some of which are a lot more specific as well. So this is broken down into 4 parts. And the way I'm going to do it is do a very quick kind of lightning version, go through this in hopefully 10 minutes or so. And then we're going to go back, go through the same stuff, but slower, look at some code, look at some examples, talk back and forth a little bit about it. If that works for everybody. So the 4 major parts here are sort of the basic stuff that we would come up with, the kind of less basic but core understandings around how to debug, and then some thoughts on like code management and what you need to do when your code base gets bigger to not lose a bunch of pieces and have it get too outdated. And then some unconventional debugging, some other things that you should think about as ways to debug that people don't usually think about. So the basics that I imagine most people here already know, but we can talk about this a little bit or a lot, are things like breakpoints, the stack trace, how to step through the code, how to use asserts and debug output, and maybe how to use preprocessor definitions as well to make sure that to kind of shuttle the debugging engine a little bit. There's a few other things that could have been on here, like watch variables and things like that. But again, it's not meant to be an exhaustive list. The really important thing here is the stack trace, which everybody just needs to have a very good understanding of if you're going to quickly figure out what part of the code is causing an issue. So we're going to come back, talk fairly quickly about just what that is and how to navigate around a stack trace. A little less basic then, when you talk to somebody about the really hard problems you face when you're trying to debug stuff, most of them revolve around threads, right? So we have multiple threads all accessing some of the same data objects, and theoretically they should all be locking at the right times and kind of not messing with each other, but there are 3 or 4 really common ways that threads can mess each other up. So we're going to look at some multi-thread examples and how we can sniff out which thread's causing an issue, how to properly debug when you're dealing with 5 or 6 threads, things not happening on the message thread, etc. Some other less basic things, there are DAW-specific debugging you'll sometimes run into. Somebody will email you and they'll say, hey, look, if I'm using your plugin as a VST2 on Windows 7 with Sequoia, it breaks. And you scratch your head and think, well, I don't have Windows 7 or Sequoia, but how can I go about debugging that, and what you maybe need to know about from DAW to DAW, how much some of these things can vary. Finally, in there, I also have release-only bugs. These are very, very rare, but there's a way that you can have a bug that only shows up in release and not in debug. So we'll talk about that. Okay, the code management, and this is kind of dear to my heart because I think about this a lot as I move through my code. And I'm not here to like tell anyone this is the sort of style that you should adopt, but I think it's very important that all of us have a sense of our own style and what conventions we want to adopt, So I'm going to kind of just share with you here some of the ones that I have done. For like breadcrumbing, so that you can see what you did, so that you can see what the code's doing, so that your comments all make sense to you, so that you don't get into a piece of code and a situation, which I've been in plenty of times, where you're looking at it going like, why did I do this? What is this variable? You know, what's going on here? And so that you also have some sense of like, which parts of my code am I maybe still testing? Which parts of my code do I have a lot of to-dos? You know, a lot of things that I need to flesh out. So all of that's very important. Dry programming kind of starts to bear here. You want to make sure you don't repeat yourself, right? Which is what dry stands for. And then comments, where you want to put comments. And then finally, when you want to override, when you want to subclass, and when you want to use inheritance or composition. I put this under code management, but a lot of people would think either that this is a settled debate or it's an ongoing debate. I think of it as a stylistic thing, because there are people that still prefer inheritance to composition, and there's a lot of gray area on where you would use one versus the other. Okay, unconventional debugging. This is a shout out to Juice, the first one there. Set application crash handler is insanely useful once you start distributing your plugin, because you can use it to print out a stack trace and email it to yourself, so that if someone on the other side of the world crashes your plugin, it can send you, next time the plugin starts up, it can send you a report, which is a good way to kind of make sure that the long tail of distribution is working out reasonably well. And then finally, custom debug UI. Once you get to a certain point where your code base is big enough, it starts making a lot of sense to build out your own UI that is not for the users, right? Some part of your UI that is for fine tuning, some part of your UI that gives you a sort of your own custom debug, whether it's graphs or a visualization of something you can't easily see otherwise, or printing out some variables. All that sort of stuff can be best done with your own custom UI sometimes. And then finally, audio as a debug output. Nobody ever thinks about this, but if we're all making audio plugins. This is going to be an audio plugin centric talk, and the audio stream itself can be used for data, can be used for output. So there's times when you're doing something complicated and you think, you know what, I don't need 2 channels of data. I'm going to take the right channel and I'm going to replace it with, some sort of data, some sort of output debug stream. So I'm going to show you an example of that and talk about when that is useful. We good so far, Josh? I'm gonna make him unmute. All right, cool. So I'm gonna go through these examples for you. We're gonna look at some code. I'm just gonna muse to myself about all this stuff, but Josh, jump in if anything's not clear.
Great.
And then hopefully we can get to questions a little early, but we shall see. Okay, so going all the way back to the basics, we're going to talk about what a stack trace is, a little bit about what breakpoints are, though that's not as much. Doing the thing you should never do. I'm going to do the code live. Okay, so this morning I just coded a couple quick examples. This is the kind of easiest crash I could come up with quickly, which is declare a naked pointer, uninitialized, and then try to use it. Right. This sort of thing used to be a lot more common than it is now, because now we have all these fancy unique pointers and scoped pointers and shared resources and shared pointers and all that stuff, which I encourage everyone to use. So you don't do this. You want to avoid, pointer to object as much as you can. But that said, we're going to see what it looks like when we quickly crash this code. Okay, so this is one of my plugins called Scratch Track. This is used for Scratch turntablism, something Josh knows about. And I added a nice nifty button here that says crash on it. And when I press this, the whole thing crashes. Oh, it did not give me the, yeah, let's put a breakpoint here and do that again. Crashed so hard it didn't even bother to give me the trace. When you get a crash, typically if you're running in debug mode, what you'll see is the stack trace. So it'll pause execution and it'll say, yo, there's a problem, and you're going to be looking at this stack. Okay, and that's what we're going to talk about quickly here.
while you're doing that, can you just tell, while you're coding, can you describe to people what a stack trace actually is?
Of course. So a stack trace, let's use an analogy. Let's assume that the program here is like a factory, and something broke in this factory. So you have a factory with many floors and machines, and something broke way up there. If someone finds that there's a broken thing and they leave a note for you and it says the wheel broke, that's not going to be very helpful, right? That is too specific of context. What you need is the wheel broke in machine number 4 on floor number 3, you know, et cetera. So you can think of it as like compartments of specificity. The stack trace is a pause in program execution that goes all the way up or down from, you know, the most general being the factory is running, all the way down to like wheel number 4 on widget number 6 just broke, right? So we're going to take a look at that. Okay, well here, it's running, so we're just going to pause rather than trying the crash button for now. Okay, so we just paused. Here is a list of all the threads, okay? To use our factory analogy, this would be all the workers in the factory, right? So there's, within the process, which is Ableton, there might be a million things going on at once. There's different threads executing. And if 2 of those threads use the same piece of memory at the same time, you can get into trouble. That's broadly, that's what the threading issues are. But here's our stack trace. Once we pause, we can take a look at everything that Ableton is doing right now, right? The main thread, which is the one that controls the UI and everything else, is not doing anything. It's running a callback, waiting, going to deliver a message if anything comes its way. All the way down to, you know, here's our audio threads. We're loading the URL. Here's our OpenGL is rendering on this thread. Now I'm going to hit play and try one more time, see if this will properly crash for me. Breakpoints is another basic component we want to talk about. So this is a breakpoint. It's same thing in Visual Studio or CLion or any of the other IDEs. You can put a little flag where you tell the program, look, if you get to this point, I want you to stop. And stop means pause, and we're going to look at the stack trace, right? So if it gets to this point, it should stop. Let's see if it does, or if it just crashes on me. Yeah, it just, oh, no, there we go. Good. So here we are, button clicked. It's right here, trying to stop, right? And it's going to crash. I'm not going to hit continue just in case it messes up. So like I said, this is one of the simpler crashes you can think of. We've created this object. We're going to try to access the object, but we can't because it doesn't actually exist. So it's going to crash. So stepping through the code is another important thing to understand, right? These buttons down here, it's called step over, I think. Yeah, step over, which makes it sound like it's not going to execute whatever's under it. But it should be like step through, you could think of it as. When you hit step over, it's going to try to execute this, and then it's going to, in our case, crash, right? Yeah, and it shouldn't have destroyed, shouldn't have closed out, but it did. Okay, let's turn that one off and go to the next one and see if it does the same thing. But the idea is that most problems can be found by, if you have a general area that you know that the problem is occurring, you put a breakpoint and you step through and see what happens. At some point, either it will crash or something will be in a state that you should be able to notice is wrong. You can hover on all of these while it's running. You can hover over any of these objects and you can explore them. You can see what the value is. You can see what the pointer is pointing to. So you can usually kind of sniff it out that way, just find what's wrong. Start this up by walking through the code. And that's the most kind of rudimentary first thing you learn to do when debugging usually. And it's something we all should be good at.
Yeah, so while he's doing that, I'll just explain a little bit further. So the breakpoint, so what a breakpoint does is it actually takes your code and actually pauses it in place. And what that allows you to do is it allows you to be able to look at the state of your different variables. So what the values of those different variables are at a given point in time. Look and see if pointers that you may have declared have been allocated, or if they're not allocated anymore. And also, and when he's doing that process known as step over, what he's doing there is he's actually just pushing the line one line forward. So he's just executing the next line of code. And that's useful. So you can see that as your once you've paused the code in a certain place, you can step through it step by step to see how your different variables change over time, and see where a particular problem may lie. That gets very specific down to one line of code.
Thank you, Josh.
Yeah.
Yeah, okay, so we're going to jump now to a simple thread related issue. And we're going to talk a little bit about threads and look again at the stack trace with this one, assuming this gives me love. And it does slow down when you're doing Zoom as well, huh? Okay, so every once in a while, somebody will write to you too, and they'll say, hey, it crashes my computer. And you'll say, oh, it crashes your computer, like the computer restarts? And they'll say, no, the computer doesn't restart. And you'll say, oh, the DAW stops? And they'll say, no, the DAW doesn't stop. It just freezes up, right? If something freezes up, that's usually an indication that you have this kind of problem, right? So I think you can see my cursor, got the spinning wheel of death. But if I click, nothing happens, right? Everything is frozen. So let's just, now in this case, the IDE won't stop. You haven't hit a breakpoint. It's not going to stop because it doesn't know anything's wrong. But I'm going to go ahead and pause. So this is just as if we'd hit a breakpoint to say, what are you doing, computer? And if we look quickly, the first thing we can notice, what's our main message thread, right? The thread that's in charge of all the UI and everything else, is right now sleeping. Juice thread sleep. It is sleeping because a button was clicked, which is, there's an infinite loop that's just sleeping, right? The importance of this is that we have two threads going on, and this one is locking, and then it's doing a task that'll never complete. So if you have a couple of threads, your audio threads going, other threads going, and one of those threads gets in a situation where it's just spinning and nothing else is happening, you will usually see an effect, a different kind of effect depending on what thread. In this case, since it's the main thread, nothing renders, right? Nothing's happening. You get the same effect, by the way, if you just comment out all of this and you enter the lock without exiting the lock. Okay, so we should talk about what these are. When you have multiple threads, where's our audio? When you have multiple threads, they can access the same part of memory, right? And you can have an issue like this, which is called a deadlock, where both threads are trying to get the lock, right? So in this case, if we get this, I should back up. This is the audio processor, and we're getting a callback lock. So I'm getting a lock that the audio processor needs in order to do the DSP work. If I grab that lock, I stop it from doing anything with the audio, right? Which is a critical problem because you never want to do that with the audio thread. The audio thread's high priority. We don't want to be grabbing that lock in most cases because you're going to slow down the audio, you're going to get clicks and everything else. But if we grab that lock and then exit or do an unsolvable task like we were just doing, you'll see it freeze up. And then you're going to look through these stacks and see if two of them are maybe doing the same thing. Two of them are fighting over a lock, right? That's called a deadlock. There it is. Okay, so Juice VST3 component, process audio, is trying to grab the plugin instant callback lock, right? Which is the same thing that we're grabbing just by pushing this button. There she is.
My dog has something to say about that.
So locks are an important thing on their own to understand and to think about. This is old syntax, this like enter the lock, exit the lock. You don't actually want to be doing that. There's a really great juice class called scoped lock, where if you grab a scoped lock, it will automatically exit whenever it leaves, right? So you don't have to worry about, well, what if I forget to exit, right? Because it's too easy to do this. It's too easy to enter a lock. Now I need to do something. And I'm going to do this thing over and over and over. Oh, but there's this one case where if this thing is true, I'm going to return, right? And you all see the problem with this is that I forgot to unlock, right? So if we have a large function that's doing a dozen different things, and 99% of the time it goes all the way through and it unlocks and it leaves, great. But 1% of the time it gets halfway down and it says, oh, I can't finish the task today, and it leaves without unlocking, then you've got a deadlock. You've got a lock that's been taken by a thread, and then the lock's been thrown out or held onto or something like that. I think that makes sense. This, by the way, is the simplest kind of multi-threading problem to debug, right? It always does the same thing. You're just spinning wheel of death, and all you have to do is look through all of your threads and find out that like, oh, two of them are both trying to access the same lock. So going a little further than that, here's a harder one to find. And this is the simplest version of this harder one to find. But there's all kinds of thread concurrency issues, right? Which, or let's just even use a broader word and just say thread access issues. Too often you have two threads that are both using the same object, right? To go back to our factory analogy, it's like if the manager told two different people to fix a machine, and these two people don't necessarily play well together, they don't have a good routine for how they work together. So what they do is they both go up there and just try to do their own thing. And one guy's tearing apart the front end of the machine, one person's doing something else on the back side of the machine, and they get in each other's way, right? You don't generally want that. You want one person at a time, one thread at a time in your code working on objects. So first of all, we just need to avoid, be very careful with what objects are owning, what objects are how they're owned, and what accesses them. So you don't necessarily want a bunch of public variables. This is one of the reasons we don't put public variables in our classes. If you have a bunch of public variables, it's too easy for any thread to access that variable and mess with it. Okay, let's try this crash again. Now this time, we're going to get a similar thing with a, oops, closed it. Going to get a similar thing with a threading issue, but it's for a different reason. So let me just make sure it works and we'll talk about that. Okay, so this time we said, hey, I hit a crash button, it did this thing, and all of a sudden the stack traces popped up and said, hey, I'm having trouble getting the length of a path, right? How did this happen? Well, in our process block, this is the DSP, so this is the audio thread. In there, I am trying to read a path, right? I have a juice object path. It's just a line with dots, and I'm going to read it. I just want to know how long it is. All good. The problem is I've got another thread, which is building that path, right? So think for a moment about how often we want to display an audio waveform or something like that. The audio waveform, this is an array of points that we're going to draw somewhere on our UI. If that is being constructed on one thread, but that audio is being used in the audio core, in the audio on the audio thread, you can easily have this kind of problem where one thread has destroyed the object, is writing to the object, is creating something with the object, and the other thread is trying to read it, right? Even fairly simple objects this can happen with. If you have an array, or if you have a pointer and it's being redirected, certainly this can happen. Most, floats and things like that are what's called atomic, so you don't have to worry about it. But fairly simple objects can still have this kind of access issue. You can't have one thread writing and one thread reading, because in the middle of a write operation, the read operation could kick in and try to read something that's only half written. And it gets, garbage code. It gets a bunch of ones and zeros that don't make sense. It gets a pointer that points it to the wrong place, and you get a crash. So in this case, it's going to be something exactly like that. So here's our stack trace again, where the top level being that the mouse is doing something. The mouse is clicking a component. Mouse up has happened internally. It sends a message. We're on the message thread, so it pushes right through to this. The button was clicked, and then the button being clicked is making a path. And currently, I'm adding, this section of the path. So all of this was successfully done. This was done. This was done. This was done. And then here, it blew up, right? What's I? 551. So why do I have this while here? Because you can usually get away with this, right? That's the problem. That's what makes these so hard to find, is that if I had only done this once, probably would have been fine. Everything would have been fine, right? Just like if I'm writing the audio data over here in the audio thread and I'm trying to read it over here in the UI thread, it's going to be fine. Most of the time, it's going to be fine. One time out of 100, though, or one time out of 1,000, or just on this one guy's machine because of the threading being a little bit different on that machine, or just on Windows 10, you can get these funny issues. So this is what makes, when somebody emails you and they're like, hey, your plugin's not working in this very specific instance. And then you go and you replicate that instance and you go, it's working fine, and you're pulling your hair out because you think this is hard science. It should work the same on his computer as it does on my computer. Here's when it doesn't, right? Is multi-threading issues. If you have two threads accessing the same thing, the timing can be completely different depending on what machine you're on. So here I tell it to do this 1,000 times, because at 550 times, it made the path over here, read the path over here, made the path over here, read the path over here, and it was fine. The 551st time, they didn't line up right, and so it crashes. So that, in a nutshell, is a very simple example of this sort of threading issue. Ways you can debug this sort of thing: when somebody emails you and they're like, hey, this is crashing and we don't know why, and you know that it's not crashing on your computer, it gets very tough. You can, first of all, you can just be more cautious. You can back up and put locks around things, if you have an idea what object you think is causing it. Secondly, you can kind of test the access to these things. You can, instead of doing a lock, you can print from several different threads. So I have 4 different threads that are all accessing this object. I'm going to print out every time it's accessed on these different threads. And then I'm going to look at that printout and see who's accessing it, when and why, and kind of go through it line by line. And that can take a long time too. So this is where you end up shooting in the dark a little bit, and you have to find, work on a hunch, basically, and then back up some locks or change what you're accessing, how you're accessing it. The best thing you can do is just not, make sure all your objects are thread safe. If you have 2 threads that need to access the same object, it should be a thread safe object. And we don't have enough time to go deep into what that means. There's things like lock-free queues, there's atomic objects, but learn what those are, make sure you're using them correctly, and be careful about how you access data that's in one thread, how you access it from another thread. So I hope that's all clear. How are we on time? Oh, we're getting there. Okay. That should be it for multi-threading. We can talk, we can go deeper on that, but let me show you just a couple other quick things. While I'm bringing this other thing up, let's talk a little bit about code hygiene. You'll notice for this demo today, I put comments, Aaron demo, everywhere that there's a demo, right? Had to alter like 4 or 5 places. So this is just, I don't want to get lost. I want to delete all this stuff after this call. You should be doing something like that, or you should think up what sort of scheme you want for your code base, just in terms of, I call them breadcrumbs, right? Things that remind you what you were doing when you were altering a piece of code, right? So I have Aaron test, right? Here's all the places where I'm actively testing some part of the code. Some place that I'm like, well, I don't know if this works properly. I need to put this in here. If I later get a crash and I find myself in this piece of code, that tells me like, oh yeah, I was testing this. I better, fix this up. I also have, I think I use temp a lot. Let me look. Yeah. So here's a bunch of temporary. So at some point I was going about my daily business. I came across this class and I was like, man, I don't know if I use this. I don't think I use this anywhere. Maybe I should deprecate it, but I don't want to do it right now because I might mess myself up. So I'm going to make a note. These sorts of notes are incredibly helpful as your code base grows, especially if you have multiple products relying on the same code base. So that you have certain classes that if you alter it, it's going to change it in 2 or 3 or 5 or 10 different products. You should have a lot of these sorts of notes so that if you change something in one place, you'll see a note later if it's affecting another place badly. I think I have a bunch for deprecating. Yeah. So here's a bunch of things that just need to go away as well that just hasn't happened. Real quick on comments. There's 2 things that everybody should do more of. I mean, they will just tell you this in college when you're getting your computer science degree. You need a lot of comments and assertions are always good, real-time assertions. So let's do search for one. Assertions are these kinds of things, right? I am, wherever I am in my code, currently it looks like I am creating this scratch track processor. And I want to make sure that the last setting I got, last parameter is a setting parameter. I don't know what that means. I know what that means, but you don't need to know what that means for the point here. The point is that assertions like this cost you nothing, right? When this compiles in release, these don't execute. They only execute in debug mode. So this is a real-time check for everything you do. You get partway through rendering something and you think, it should really be, under 1. The value of this thing should be less than 1. Put in an assertion that says, assert this thing is less than 1. If you think that there's any chance it's not. The reason for this is you'll catch lots and lots and lots of errors this way. Things that you thought were bulletproof, but you put in a couple assertions and all of a sudden in a slightly different situation, you've thoroughly tested it, but in a slightly different situation, an assertion pops up and tells you, whoops, something didn't go the way you thought it was going to go, right? Real-time assertions are a valuable tool. You should put them everywhere. The other thing that I use a lot of, and some people will tell you, you shouldn't, well, comments first, we didn't talk about, and then debug outputs. Comments, I do a lot of comments, and the way that I like to do them is putting action verbs first, right? So that I can go through it quickly and I can say, okay, I'm going to override something, then I'm going to output something, I'm going to do something with MIDI, then I'm going to process these things. Down here, I'm going to check something, right? This sort of thing so that you can go through quickly and you should be able to read your comments and know exactly what the code's doing. That way, when you come back to this code, when there's a problem 4 years from now, you don't look at it and go, oh, what was I doing? What is this doing, right? Always, write what it's going to do and then block of code. Write what it's going to do, block of code. I find that very, very helpful. I didn't do it for many, many years, and it nipped me in the butt a million times, and I'm getting better at it. Debug outputs. You notice, I'm sure you've been watching down here, I use quite a lot of debug outputs. Not everybody agrees you should do that. A lot of this, again, it's only going to happen in debug, so it doesn't matter in terms of performance, but it's clutter, right? So if you can output everything that's going on with the code, and then when you're looking through it, the execution, you can say, oh, this happened, then this happened, and make sure, it gives you a kind of a sanity check. Or you can output nothing, and then occasionally output, just what you're currently testing. It's easy to use macros to shut these things off. So I won't demo it for time, but here, like this. There's this class that interfaces with an API. So it does a whole lot of like pinging a web server and stuff like that, which tends to clog up my output. So if I'm debugging something that has nothing to do with that, I want to be able to shut off those debug statements. Easy to do. In this case, I just override just for this file. This is a CPP file. So there's a definition at the top of it that just for this file is going to override debug temporarily. so that it doesn't actually output anything. So this won't happen, right? Because it's defined locally to not do anything. The usefulness of that is that I could now take this definition, I can put it in a settings file somewhere, and then when I'm debugging the API, I can go one, resave, recompile, and I'll be viewing the output related to the API, but not the other stuff, right? So if you're a person like me that likes to do a lot of debug output, you can do this to silo it. So you're just viewing relevant debug output. I hope that made sense. Josh, you with me? That's all the, that's most of the like code management, high level, like you're growing your code base. Here's some like tips on code cleanliness, shall we say. Got
Yeah.
anything to add?
No, you pretty much covered it all.
Oh, I'm sure I didn't do that. I'm sure there's lots more, but we're going to move on. So I want to show you real quick two sort of less conventional ways to debug that people don't really think about very often. And then we'll just kind of open it up and see what people want to talk about or what I skipped or what could use more clarity. Here comes Ableton. So the two ways we're going to talk about are how to build your own debug UI and when that's useful, and how to use the audio stream as output and when that's useful. So I'm going to do it real quick. So here's this thing again. I have a special area here where I've built it out to the point now that it knows I'm an admin, so that normal users don't have this admin menu, but I do, and it's got all these special things I can test and do and whatever else. So it's kind of a custom testing suite. So here for this plugin, we have this debug output, which does two things. This is a scratch tool, which means it resamples on the fly. Resampling can be pretty complicated. You can get all kinds of issues at the borders. So at some point I realized, well, I can't figure out how to debug this really well. Doing it this way and drawing my own curves, I'm able to get a really good look at it. General rule is things become a lot easier to debug when you can see them. There are many, many, many things, data streams and everything else, that something's not working correctly. And if you think about it, you're not looking at it in any sort of detail the way you'd like to. So you need to, back up and say, what do I need to build so that I can really see this problem, right? If it's something that you can hear in the audio stream, it can be really helpful to also see it. If it's not, if it's something, in the data, you have a massive database, you have a value tree, you have all this other stuff, then maybe build something where you just view the value tree, right? Where you can collapse and uncollapse the values and look around and, oh, that value is not what it's supposed to be, that sort of thing. To a degree, you can do this just by pausing execution, but a lot of times that's not ideal. So this ends up being better. Oh yeah, look at that. It also, yeah. I think I also had, here also is the crossfader on there, which the mouse is a horrible piece of input for this, because you get a very choppy, there you go, very choppy signal. So maybe I want to add smoothing to that, right? Except I don't, but in some cases you can look at it and it can give you a better sense of your signal. Since we're dealing with audio debugging, another thing that can happen, you've got some clicks. Your audio plugin, whatever it's doing, has these weird clicks. Every once in a while it clicks and I don't know what's happening and I need to see it. And maybe you get to the point where you look at it in the DAW. So you're playing your synth or you're running your reverb or whatever, and you can see the nonlinearity, right? You can see a spike where it's not doing what it's supposed to do, but you don't know why, and you don't know what the code is doing at that moment, right? An easy way then to get a good look at what the code is doing at that moment. One is to do your own debug, as we just talked about. The other way is to hijack one of your audio channels, right? So for example, right down here, example 5. For example, we're gonna right here take the audio output and get rid of, here's channel 1. We're gonna overwrite channel 1 with the frequency. The frequency is, that's the thing we were just looking at. So the play speed or the turntable motion, you would think of it as, and we're going to put that on in the audio, in the left channel, right channel. You guys hear that? Talk about that in a second. Route 1 to 2. Record. I'm just going to quickly record something, and we'll take a look. Okay. So user has hit play, user has scratched back and forth a little bit, and we want to take a look at what is happening. The top channel there is the audio, right? That was just recorded. So in this case, again, if it's a synth, if it's something else, you can now see exactly what it's doing. So because this is a resampler, sometimes when you get close to 0, you'll see all of a sudden, the waveform changes pretty dramatically. Now, in the event that there was an error somewhere, right in here, I could find an error. It would be very easy to go down here and say, well, what is the current frequency doing? Except it actually got some of the other channel too somehow. These spikes, by the way, are for the border. So it's also very helpful sometimes to know exactly where your blocks are, because you can have boundary issues where the first sample in the block or the last sample in the block is the problematic one, because there's a boundary there and you didn't properly remember some state. Mess up a filter, for example, that sort of thing. So yeah, there you go. So you can see this curve here is basically the same curve that we just had previously. I guess it didn't clear some of this data for some reason. And then you're putting a debug stream on the other output so that you can get a really good look at what's going on. This isn't limited to anything really. I could print the current value of pi. You could print the current rotation, the current time. You could have a little timer that does this for every second. So it's really, you should feel unconstrained at the amount of data you can put in there, and it's a enormous because it's sample accurate. There's so many of them. There's quite a lot you can do when you start thinking about the fact that you can use this as a debuggable output, as a valuable data stream. Oh, that's why it's also recording this. All right. So that's that. Those are the last 2 examples. I'm going to pull the, come on back with me, Josh, and I'm going to pull up the outline to see what I might have missed.
Great. Well, while you're doing that, we have a question from Akash. Hey, Akash. Who says, great stuff, Aaron. How do you deal with a customer who sends you a crash report since they're using a release build with no debug signals? The crash report doesn't contain a lot of detail. Yeah,
so I cheat. I leave the debug symbols in on Mac. I don't do that on Windows because it's very hard. The professional way to do this, though, is to do something called d-symbol location, which is you keep the, what's it called, the manifest file or something. Every time you do a release build, right next to it, there's a thing that maps all the symbols, that tells you where all the symbols are in the code. So what you're supposed to do is take the stack trace that's been sent back to you, reverse, d-symbol locate it, and then that just decodes it back to the actual readable stack trace. So good question. If you're not too worried about hackers looking at your code, you can also just leave the symbols in there, but it's not advised.
Great. That's the only question that we really have. I was the only other thing that I thought, I'm not sure if you use this at all. Do you use GDB or LLDB or anything like that?
Yeah, I mean, those are two different compilers. I'd have to look which is the standard now, is the LLDB, I think.
LLDBs for Xcode.
Yeah, which I mean, I switched right when GDB switched, so I've used both, but I haven't given a lot of thought to comparative advantages or anything else. I know there's a debate out there about that.
Okay. Well, I guess what I mean is just maybe just letting people know what it is in general.
Well, sounds like you got a better handle on it than I do. Why don't you explain it?
Yeah, okay, so if you want to pull up Xcode again really quickly.
Yeah.
And just maybe do like a breakpoint. So there's another tool that that you can use that a lot of people don't actually know about, which is in Xcode, is called LLDB, which is actually almost a language in itself. And what you can do, I don't actually even remember how to like any of the coding conventions or anything.
You're
like
going to talk about putting a command in the console?
Yeah. Yeah, so what you could do is you can do it's bits of debugging that actually allow you to find out more information if you when you hit a breakpoint or when you hit a crash, and that's really useful sometimes. Another tool that Aaron didn't really cover this one, but is also very useful, is conditional breakpoints as well. So which are where you can actually set a breakpoint that will pause execution. So if you have a for loop that's running and you say that you want to actually pause execution after the for loop has happened 1,000 times, you can actually do conditional for loops. And there's kind of specific syntax that you need to do to be able to be able to do those things. And I'm sure that there are resources on the web. But if you're looking to dig even deeper on debugging, those are two great places to check out.
Yeah, LLDB, I don't use all that much either, which I probably should look at it more. But yeah, when you pause execution, there's a wide variety of things you can do. So you can print out, you can just pause execution and say, what's the value of a certain variable right now? And you can, ask the debugger and it'll print it out for you. Here it shows, I guess you can create new objects and all kinds of stuff. So yes, that is a whole other area. A lot of people also like watch variables. You can, particularly in Microsoft, in Visual Studio, you can tell it that you want to watch a dozen different variables, and it'll just keep those in the debugger at all times, so you can keep an eye on them, which is also something I don't do very much of. So there's, like I said, it's not an exhaustive list, and there's a lot of other takes on this, and there are also a lot of third-party tools, particularly for the thread debugging, that I haven't used very much of, but there are people that swear by them.
Yeah, absolutely. Xcode's I forget how to access it in Xcode, but if you go back to Xcode again, maybe so in debug, so if you go into the debug menu at the top, so you have like thread sanitize. Another thing that you may want to mention is like thread sanitizer, or maybe it's in
where are you looking? I don't know what that is.
Really?
Yeah, you're blowing my mind.
So if you go into where's product, so maybe if you go into I think if you go into product and then scheme, and then do edit scheme,
Oh.
and then go into diagnostics.
Yeah, we didn't talk about the profiler at all either. Address sanitizer, thread sanitizer, requires recompilation.
Yeah, so these are really useful. So yeah, so you have address sanitizer, which ensures that after pointers that the pointers are deallocated and destroyed correctly, then you have undefined behavior sanitizer, which looks out for undefined behavior. Thread sanitizer, which is where it looks for thread racing conditions.
Yeah.
So those are great to turn on. Those only work, if I remember correctly, in debug mode. So
yeah, I would hope so.
yeah,
That's cool.
those are really cool as well.
I have not tried either of those, and I'm going to right after this call, because now I'm curious.
Oh, you don't know about this? I taught you
No, I
something.
don't. I've never used these. I would hope they're new, but maybe I just haven't noticed them for 15 years.
No, they've been out. Yeah, yeah, they're great.
Um,
They're great, and they're really a pain because they're very strict, but they're very useful.
There's also, and we would be remiss if we didn't note that Juice has a fair number of like safeguards too. First of all, there's a lot of assertions in Juice, which is helpful because you'll be going about your business and suddenly there'll be an assertion in Juice will pop up and say, if you hit this assertion, it's because you didn't, and you have to change something. And then they also have a lot of memory leak detection.
Mhm.
So most objects have a little macro at the bottom of them that says like declare something with memory leak protection, and then whenever everything is destroyed at the end, everything is deallocated. If you have leaked, if you have not destroyed something, Juice does a really good job letting you know.
Yeah. Cool. I think that's everything. Yeah, James had a great comment. He said, this great talk, this very useful information. I would have never thought of commandeering a channel of audio, but I'm
Yeah.
certainly going to use that going forward.
It's a fun way to do it.
Cool.
Oh, all right. Well, thanks, Josh. This was fun as always.
Yeah, fantastic.
Thanks
Thanks.
everybody else too.
Thanks so much. Oh man, I'm
But they
jealous.
sat through it.
I'll be having a cup of coffee. Nice.
It's all good.
Yeah. When there's a coffee in hand, it's always all good.
Yeah.
Cool. So as we said, yeah, if you're going to be at the Audio Developer Conference later on this month, we hope to see you there, whether in person in London or virtually online. And look forward to seeing all of you there. And then for us, our next meetup is going to be on the 13th of December. So it'll be our Christmas, it'll be our pre-Christmas special, pre-2023 special. So hope to see you there, and we have some exciting guests coming up, and we will be able to announce those soon. Other than that, that's it. Thanks everybody for tuning in with us, and thank you to the presenters as well. So and with that, we will go ahead and sign off. So hope to see you all next month, and
Bye-bye.
at
Thanks,
ABC.
Josh.
All right.
Stuff. Cheers.